Hi guys. I did not know that the first talk was going to be so happy about bare metal. I'm working at Leaseweb in the bare metal infrastructure team, so that's cool for me. Was not planned, I swear. Today I'm just going to show you what part of what goes on behind the scenes of an infrastructure as a service company. For those who don't know a little bit about Leaseweb, we're 20 years old. We have 16 POPs all over the world. We have 80,000 plus servers. We're vendor agnostic. We buy whatever is cheapest at whatever point. And we have a 2.5 terabits global network. For the people that work at Algolia, these are your servers. This is what they look on the inside. This is what they could look on the inside. A lot more fun. But you don't pay for that, so you don't get that. I'm going to talk about the order process for dedicated servers. I only have 15 minutes. I can explain for hours how an infrastructure as a service works. But so to narrow the scope, I'm just going to look at the order process. So there's two types of order processes at Leaseweb. You can buy whatever you want if you have a specific need. For example, if you want GPUs, we don't normally have them, but we do have them. So you can order them. So there's two different order styles. There's stock delivery of things that we keep in stock that are already in the data center that maybe another person already used and we're reselling to you, or we have custom built solutions. Most of Algolia servers are actually custom built because they want a really high gigahertz CPU in them. So that's why most of their servers are custom built. But actually, this server, DL120G9, is one of our basic servers. So the chassis and the motherboard and the drives and all those things are standard parts. The only thing we order for Algolia is the CPU. So how does the order process look? Basically, we procure the parts. When Algolia says, okay, we need 60 servers spread out over the world, we order the 60 CPUs. The rest of the chassis we probably have in stock, or we order the excess parts that we need. We get just-in-time delivery. We assemble the servers. We start testing them and install an OS on them in the installation room. So we have a dedicated room in each data center where we basically assemble hardware. We then rack mount it somewhere in the data center. Algolia usually asks us, we want them as spread out as possible. So if we have an issue in the data center, let's say in hall 1, our servers in hall 2, 3, 4, 5 are not affected. So we do that. Some customers say I really want them in one rack or two racks next to each other for like performance, high frequency trading, or when interoperability is really important. When the server is actually in the rack, we do an automation test. Usually we do an IPMI reset. For those who knows what IPMI is? Okay, 2, 3, 4. Okay, I have something to show you guys. And then we deliver the server to the customer. And indeed, it can all be done with an API, but all behind the scenes, it's all humans running around in the data center. So you don't need your entire team to manage bare metal servers, because we have a team that manages bare metal servers for you. So in case of Algolia, just to explain, I'm going to show you some pictures of the data center. We use 4-letter account codes. So this is the account code for Algolia, VWMK, for the Netherlands. And all servers have a unique ID that doesn't change. And then this is how a random rack of Algolia servers actually look. I made a data center engineer go to the data center and take pictures of your rack. I'm sorry. Privacy, I know. So this is a random rack of your servers. What you can see is each server has a random ID that doesn't change. So that's a unique ID for a server. And then on this server, you see the account code of Algolia. And then this is apparently the 36th server they ordered in the Netherlands. If you go down, there's more Algolia and other customer servers. It's whatever we want to order, and if one server gets canceled, it's possible that it gets taken out of the rack and then reprovisioned, or another CPU put in, or that it just stays in the rack and it gets sold if it's a standard model. This is what the back of a rack looks like, or what of the back of this rack looks like. In the top, you see, well, you can't see, but There's a 2U automatic transfer switch. If a rack has 2 power feeds, but it only runs on one, this unit makes sure that as soon as the power feed where it's actually running fails, it switches over to the other one with 0 downtime. It's just constantly monitoring the power feed, and then it flips over to the other one. Then on the sides, you see PDUs, there and there. With these PDUs, you can actually remotely turn on and off the power. So if you want to reboot, these things just have a UTP connection, but we have an API call you make. You say, okay, API for server, I don't know, 3.4, blah, blah, 3.4, reboot, and it will turn off and on the power port or via the remote management module. So when I asked the engineer to take these pictures, he got back to me, and he was really disappointed that I wanted pictures of this rack because it didn't look right to him. So instead, he took pictures of another rack, a random rack, I don't even know which rack, and he insisted that you should look at this. Just to give you an example, we have 3 switches in a rack. One for the public network, you see 2 10 gig uplinks, one for the internal network where you can get a private network between all your servers, and one for the remote management, which is a cheap switch because it doesn't do anything traffic. This was another picture he insisted I show you of neat cables. This is what so we have multiple generations in our data center. 20 years organically grown. So this is one of the old halls. What you see is an enclosed rack space. This is the cold alley. Cold air is coming up from here, going into the racks and blowing out on the sides. So this is the cold alley. This is the warm alley. If you're standing here maintaining a server, it's actually warm. It's very uncomfortable. This is what the hall looks like. So we used to have big halls with like 40 rows of racks or something like that. And each rack has a code. So you can easily navigate to hall 1 and then row GD and then rack 23 or something like that. Okay, I'm just going to show you behind the scenes now. Since you don't know what an IPMI or an idle or a DRAC is, this is a bare metal server, a random server from our test account. This is the BMC or the DRAC as the Dell calls it. If you fuck up your SSH config or your network config and you need to recover your server, this is the way you do it. There's a little computer on side of your motherboard, which basically gives you the ability to see what is on the keyboard. So instead of running to the server and attaching a keyboard, mouse, and the screen, you do this. There's 2 varieties. You can either use the Java console, which is a bitch. Hate the thing. You always have to like exclude security options and it's terrible. Or you can do the cooler thing, which is IPMI. We wrote a small tool called Consoler, and you give it a server ID, and then it connects to the IPMI. It fetches the credentials from our API, and then you connect, and you see exactly the same thing that you see here. Now, that's one. So this is actually our employee backend, but if you're a customer, you see the same thing, but a little less. So we do all these things for you. For example, we have automation that prepares a server for sale. So let's say Algolia ordered a server and they're saying like, we're done with this project, we're giving back the server. This is the job we would run. So you would see, we generate a new set of credentials. We remove the old credentials from our secret storage. We create a DHCP lease for the server. We open up all the switch ports. We power cycle the machine. We wait for it to PXE boot. And then we wipe all the partitions, which is just a bash job of nuking any possible information that might be on the drive. Then we reset the ILO or iDRAC or whatever the vendor tool is to factory default. Then we do a scan of all the information that is in your server. So we scan what type of hardware is it, how is it connected to the network, what type of RAID config do you have, things like that. and then we reconfigure the iDRAC that I just showed you, and then we set some BIOS options for you, which is basically configuring the iDRAC that I just showed you. We do firmware updates for you, so every time you get a new newly provisioned server, we make sure that you're running the latest firmware. And we do this for all vendors. So if you want, here's the batch job that you can run on every server. So we reboot servers and then do another hardware scan, set some BIOS settings. And then the server is ready for sale. We actually power it off. And then it just waits in our inventory for you to order it. But to show you that bare metal is actually not that hard, I'm going to provision 2 machines for you. Two random servers from a test account. I want to v1 install, or what should I do? No, I want to run a live OS on this. Okay, so this is basically our API calls that you can also do, but just for the front end. I'm running a live OS on this thing, so I want to say, okay, I want to, for example, all our automation runs in this live OS. Actually, I think your customers, it's more interesting for you if I just install an OS. So here is what a customer would also see. I have an OS. Do you have any preference of which OS you want? Really doesn't matter to me. CentOS, good. Do you want software RAID? RAID 1? Oh, we have 4 disks. RAID 5. Well, do you want any specific partitioning? I don't. Want a control panel? Not implemented, sorry. Give it a host name. Give it my SSH key. Post install script. So after the installation, if I want to like onboard it into Chef or Ansible or Puppet or whatever, you can run whatever arbitrary bash script you want in this thing. You can send a callback notification to your own inventory system saying, okay, the installation is done. I'm not going to do that. At the moment, it says, are you sure? I'm absolutely sure. Okay. And now we go back to the Java thingy, and it made a job for us. So you see it created the DHCP lease, and it opened this, it's currently opening the switchboards. It's done. It power cycled my server, and now I'm waiting for a Pixie boot. And the only shitty thing is now my connection also dropped because yeah. Okay. So no, wrong server. This? The tilde dot? Is that what you're saying? Oh no, I didn't make a mistake. It's the picture of the PDUs I showed you. Yeah. So these things on the side are what we primarily use for powering off servers, but they do a hard power cycle. There are 2 ways to power cycle a server. It's either via the BMC where you say, please reboot, and then you hope, fingers crossed, that the server reboots, or you just yank the power. we usually yank the power. It's not great for your server, but it guarantees that you reboot. And that's what happened. So I lost my connection to the out of band as well because that lost the power. But I should be able to just see it come back. Anyway, in the meantime, I also have a little video, and I'm running out of time. So I'm running this video in the background. It's about how we construct our data centers. Any questions? It's on YouTube. If you want the link, you don't have to record it. Any questions? Okay. I'm just going to let it play. All right, that was it. New data center. Maybe the install started? Yeah. Ooh. Starting a job. Okay. I'm out of time. Basically what you're showing is it's showing you the task that it's doing and then the output on the screen. So if you see here that it's finished, oh, it failed. Oh, well, need to look into that.